Okay, you're given this indefinite integral and asked which of these choices is the correct antiderivative. Turns out it's B. Here's proof. Here's the graph of the original function, which is the red curve here. F prime of x turns out is identical to that. And here's the antiderivative that matches what we have in part B. That's actually this blue graph here. To actually manually calculate the antiderivative, we've got to use one of these identities for the cosine of twice an angle, and it's going to be this one. And if you solve this for cosine squared x, then the cosine of 2 theta, I'm using theta instead of x, is 2 cosine squared theta minus 1. Add 1 to both sides and then divide by 2. This expression here is equivalent to cosine squared of theta. Okay, now if we raise that expression to the fourth power, well, we got to square this factor. That's the 1/4, and then apply squaring a binomial here, gives us the perfect square trinomial. And then our goal is to replace theta with 3x because we actually have cosine of fourth of 3x, not theta. So wherever we see an theta in this formula, we're going to put in 3x. And so 2 times 3x gives us 6x here and 6x here. Okay. And to reduce this even further, we're going to replace cosine squared of 6x. We're going to reduce it the same way we did this guy. Okay, so if we go to board 2, this is what we want to replace right here. And we know that that's 1 plus the cosine of twice whatever this angle is, 6x. And everything else stays the same. If I break this apart into 2 terms by dividing each term by 1/2, 2 times 6x is 12x. Add the 1 and the 1/2 gives us 3/2, and then distribute the 1/4. This is what we get. And then we want the antiderivative of 5 times this. So if I multiply every term in here by 5, that's our equivalent expression for 5 cosine to the fourth of 3x. So here's everything multiplied by 5. This is what we want to find the antiderivative for. And so if I break this apart into separate indefinite integrals, 15/8 antiderivative of dx, 5/8 antiderivative of 12x dx, plus 5/2 antiderivative cosine of 6x dx. And of course, you can use u substitution for this. Let u equal 12x, dx equals, du equals 12 dx. So that means we got to put a 12 here. So we got to put a 1/12 out front. That's where this 596 come from. And the same here, we got to put a 6 out front. The antiderivative of sine of a cosine 12x is sine 12x. So I can finish up here 15/8 x, and I'll put this term second, plus 5/12 sine of 6x plus 596 sine of 12x. Okay, plus constant of integration. So it turns out if you take the derivative of this, you will get 5 cosine to the fourth of 3x. And there you go. Hope that helped. If you have any questions, post a comment.